Good morning, students. Students, please check whether voice is audible or not. Am I audible? Okay, I hope it is clear, right? You are using the speakers for your headphones. Okay. So, how was yesterday's exam, students? How many of you attended? Only few sent the papers. What about others? Yes. Why did you attend the exam yesterday? On Saturday, sorry. Do you have any reason for not attending the exam? Okay, so let us start with the class. So I hope you have done those remaining examples which I have given in the homework. Have you all done, students? Those examples of exercise 5.6. Any doubts from those? If you are feeling any sum to be difficult, please just let me know. We will solve it here. Have you all solved those examples of exercise 5.6? Please answer. Okay. So higher order derivative, let us start it once again. Suppose we have a function say y is equals to f of x. If you are differentiating it for the first time, what you will get? You will get dy by dx is equals to f dash of x. This is nothing but first order derivative. Right? Means you are differentiating a function for the first time is nothing but first order derivative. Now, if this f dash of x is differentiable, means if we can differentiate this f dash of x once again, then what we can do here, we can differentiate that. That is d by dx of differentiating it again. D by dx of dy by dx. This dy by dx is first order derivative. You are differentiating it again with respect to x. That is d by dx of dy by dx. This can be written as d square y upon dx square. This can be written as d square y upon dx square. And this is nothing but second order derivative. So, if this f dash of x is differentiable, and if you differentiate it again with respect to x, what will be students? D by dx of dy by dx is equal to d square y upon dx square. And this is nothing but you can call it as second order derivative. Similarly, if this d square y upon dx square is again differentiable, you can again differentiate it with respect to x. So if you differentiate it with respect to x, what you get? D by dx of d square y by dx square. And that is nothing but what? d cube y by dx cube. That is nothing but d cube y by dx cube. And this is nothing but third order derivative. It is nothing but third order derivative. Similarly, if we go on repeating it, we will get higher order derivative. So I hope you understood what we are doing here, students. First, when we differentiate it for the first time, differentiate the function for the first time, you will get first order derivative. And if this f dash of x is differentiable, only if it is differentiable, we will differentiate it, right? So if it is differentiable, we will differentiate it again with respect to x. That time what you will get? D square y by dx square. And this is nothing but second order derivative. Similarly, if you differentiate it again, you will get d cube y by dx cube, and that is nothing but third order derivative. Similarly, if you go on observe here students. Now I want to find the higher order derivatives of this. First of all, let us find the first order derivative. Means what? Differentiating this function for the first time with respect to x. So if you differentiate this function with respect to x, what you get? 3x square plus 10x differentiation is 10. So this is my first order derivative. This is nothing but my first order derivative. Okay, so what we have done here, we have differentiated the function with respect to x for the first time. Differentiation of x cube is 3x square plus differentiation of 10x is 10. So this is my first order derivative. Now if I want to find the second order derivative, what is the second order derivative? Differentiating it for the second time. Differentiating dy by dx with respect to x. That would be what students? D square y by dx. Now if we differentiate this first order derivative, what we will get? We will get second order derivative. So see here students, differentiating 3x square. What is 3x square? We will get that 6x. See, x square differentiation is 2x. 2x into 3 is 6x. Plus differentiation of 10, of course it is 0. So that comes 1. So what is d square y by dx square? It is nothing but 6x. And this is nothing but second order derivative. It is nothing but second order derivative. Now again this 6x is differentiable. So you are able to find the next derivative, right? So again differentiating with respect to x, what you get? d cube y by dx. You get d cube y by dx cube. So what is d cube y by dx cube? Differentiate with 6x again. What you get? You get 6. So this 6 is nothing but third order derivative. Like this, you will find the higher order derivatives. First order derivative, differentiating the function for the first time. Second order derivative, differentiating the function for the second time. And third order derivative, differentiating the function for the third time. These are nothing but higher order derivatives. Now let us see the notation. Let us see the notation. Now if we have the first order derivative, how we can represent it students? First order derivatives are represented by, see we have many ways to represent the first order derivative. How you shall represent it? You can either represent it by dx, or you can represent it by a dash of x. Right? These notations you must be knowing students, because in different textbooks they will denote it by different ways. First order derivative is either denoted by dy by dx or dash of x, or either it is d by dx of f of x. Right? D by dx of f of x, or also you can denote it by y dash of x. This is the only y dash you can write, means first order derivative. Once. Or either you can denote it by y1, like this also you can denote. Or also you can denote it by here you can represent it by x square by dx square, or yeah, double dash of x, or d square by dx square of f of x, or y double dash, or y2, or del y del square y, or d square. So these are the representative notations of second order derivative. Right, students? Second order derivative you can represent it like this. Either you can represent it by d square y by dx square, or f double dash of x, or d by d square by dx square of f of x, differentiating it twice, or either you can say y double dash, y2, or del square y, or d square. This is again inverse representation. So these are the notations of higher order derivative. Similarly, third order derivative, fourth order derivative, and so on. Okay, students. So like this, we will represent the higher order derivatives. Now, the concept of higher order derivatives is clear. Is it clear, students? Is the concept of higher order derivatives clear? Including notations. Is it clear to you all? Now let us see some problems of exercise 5.7. Exercise 5.7, first one, find the second order derivatives of the functions given in exercises 1 to 10. We have to find the second order derivative. This is right. First one, function what it is represented, so what we consider it as x square plus 3x plus. Now of this function we have to find the second order derivative. So how we shall find second order derivative? To find second order derivative, first important thing is we have to find the first order derivative, right? And after that, if the first order derivative is differentiable, only then you can find the second order derivative. These two things you should be careful with, students, while finding the second order derivative. Now, suppose this is y. So first of all, let us find the first order derivative, that is dy by dx. Means differentiating the function for the first time. So if you differentiate for the first time, what do you get? Y is equals to x square plus 3x plus 2. What will be dy by dx, students? If you differentiate y with respect to x, what will be dy by dx? Very good. Differentiation of x square is 2x plus differentiation of 3x is 3. So yes, this is my first order derivative. This is my first order derivative. But they have asked us to find what? We have to find second order derivative. That is nothing but d square y by dx. Means differentiating the function twice. Or you can even say that differentiating the first order derivative. Right? What is the second order derivative? We are differentiating the first order derivative, right? So if you differentiate this first order derivative, that is 2x plus 3, what answer you get, students? Differentiation of 2x plus 3, very good. It is 2. Differentiation of 3 is 0. Differentiation of 2x is 2. So this is my second order derivative. So like this, we need to find the second order derivative. Let us go for the next question. Differentiation, when you want to find the second order derivative of x to the power 20. X to the power 20. So what will be the first order derivative? dy by dx. Differentiation of x to the power 20. Yes, what is differentiation of x to the power 20? Very good. So it is 20 x to the power n minus 1. It is 19. Differentiation of x to the power n is what? It is n x to the power n minus 1. So differentiation cos x. Observe here students. Y is equals to x cos x. So it is a product of two functions, right? It is product of two functions. So here comes the use of product rule, or you can even say it as Leibniz rule. So let us use that here. Now first of all, let us find the first order derivative. Is differentiating the function for the first time. What answer you get? If you differentiate x cos x, what you get students? I want the right answer. Please use Leibniz rule here. It's not just x sin x, it's not. Tell me the right answer. No, Zinali, that is also not correct. See, we are going to use the Leibniz rule here. Means what? Keeping the first function as it is, differentiating the second function, plus keeping the second function as it is and differentiating the first function. Please remember these rules. UV dash product is equals to U dash V plus V dash U. U dash V plus V dash U. So now let us use this concept here. Let us keep the first function as it is. Second function cos x differentiation is what? It is minus sin x plus keep the second function as it is and differentiate the first function. Differentiation of x is this is the first order derivative. This is first order derivative. Right? It is minus x sin x plus cos x. I hope you understood now. Usma, Aishwarya, Zenavi, those all have answered. Right? You wanna use the Leibniz rule very perfectly. Do not make mistakes. Silly mistakes. Okay? Now this is a first order derivative. Now let us find the second order. Means differentiating the function twice. Observe carefully now. Now we are going to differentiate the first order derivative. Right? Means what? We are going to differentiate each and every function here. Now first let us consider this. Differentiating minus x sin x. Minus sin take it outside. Now we have to differentiate x sin x, right? Again what we are going to use here? We are going to use here this rule. Because again it is product of two functions x sin x. So if you use Leibniz rule here, what will be the differentiation? Then now right answer. Again use the product rule here and tell me the differentiation of x sin x. Differentiation of x sin x. Yes, what is differentiation of x sin x? Yes, students, what is differentiation of x sin x? Why there is 1 divided by Aishwarya? See, again we are going to use the product rule here. Keep the first function as it is. Differentiate the second function, that is cos sin x. Differentiation of sin x is cos x plus keep the second function as it is. Differentiate first function. Differentiation of x is 1. So this is differentiation of my x sin x minus differentiation of x sin x is this x cos x plus sin x plus. Now here differentiation of cos x is what? It is minus sin x. So this would be minus sin x. Now simplify it. What do you get? Minus x cos x minus plus minus sin x minus sin x. So what answer you get, students? You get minus x cos x minus 2 sin x. This is nothing but second order. This is nothing but a second order derivative. I hope you understood. See, first in second order derivative, while finding the second order derivative, minus sign I have taken it outside and differentiated this x sin x. Now again x sin x is product, so you are going to use the product rule. X keep as it is, differentiation of sin x is cos x. Plus sin x keep as it is, differentiation of x is 1. Next, we have to take plus here. Differentiation of cos x is what? It is minus sin x. Then simplify, you will arrive at the answer. I hope you understood this rule. So here we have used Leibniz rule twice. First in first order derivative and second in second order. So this is nothing but a second order derivative. Let us go for the next one. Fifth question. Sorry, fourth one. Y is equals to log x. Y is equals to log x. Now tell me what will be my first order derivative? First order derivative, that is dy by dx. Let's tell me what is first order derivative? Differentiation of log x. Very good. It is 1 by x. Differentiation of log x is 1 by x. Now what is second order derivative? Is the differentiation function twice. And then the differentiation is first order derivative. What is differentiation of 1 by x? I told you it is standard formula. And I even told you to remember the standard formula, right? Very good, Aishwarya. It is minus 1 by x square. Differentiation of 1 by x is minus 1 by x square. So this is my second order derivative. That is my second order derivative. Fifth question. Fifth again it is very confusing. Be very careful. It is x cube log x. It is x cube log x. So again this is the product of two functions. So here we are going to use the Leibniz rule, or else you can call it as product rule. So what will be my first order derivative? Can someone try? First order derivative. Use Leibniz rule here and arrive at the correct answer. Differentiating the function with respect to x for the first time is nothing but first order derivative. I am repeating it again and again, students. So what will be my first order derivative? What is differentiation of x cube into log x? Yes, anyone? Apply the product rule properly. X cube into 1 by x plus log x into 3x square. Very good, Janavi. Right answer. Observe the students. We are going to use the product rule here. Keep the first function as it is, x cube into. Differentiate the second function. What is differentiation of log x? It is 1 by x plus. Now keep the second function as it is, that is log x into f is into. Differentiate the first function. What is differentiation of x cube? It is 3x square. It is 3x square. Now simplify. 1x gets cancelled, so this x square is plus 3x square into plus 3x square into log x. So x square plus 3x square into log x is my first order derivative. What is the first order derivative? X square plus 3x square log x is my first order derivative. Now let us find what is second order derivative. What is second order derivative? D square divided by dx square. So here you are going to differentiate each term. Right, students? So what is differentiation of x square? It is 2x plus. Differentiation of x square is 2x plus. Now observe here. Let us take this 3 outside. We have taken this 3 outside. Differentiation of x square log x. You can observe here again it is product. So you are going to use the product rule here. Right? X square log x is product. So you are going to use product rule. So x square log x differentiation will be x square into that is differentiation of log x is 1 by x plus log x into that is differentiation of x square is 2x, right? Let us simplify now. What will get? 2x plus 1x gets cancelled, remaining 15x is 3x plus 2x log x into 3, that is 6x log x. So 2x plus 3x is 5x plus 6x log x. This is my answer. So this is our second order derivative. This is our second order derivative. Very good. Right answer. So what is the second order derivative? Another derivatives. Oh. Let us go to the next question. Six. Y is equals to e to the power x sin phi x. Again, here this is product. So we are going to use the product rule or Leibniz rule. See, e to the power x, it is what exponential function, right? You can more detail you can say that natural exponential function. We have learned this, right, students? In logarithmic function and exponential function, we have learned this. This is nothing but natural exponential function. Now, this is product. So let us use the product rule. First order derivative is what? dy by dx. Can you try students? What is dy by dx? Use the product rule. Step by step you go. And tell me what is first order derivative here? What is first order derivative? First function, keep it as it is. E to the power x into. Differentiate the second function. Now observe here students. Sin phi x, it is composite function. Right? So I hope you remember how to find the derivative of composite function. Which rule you will use in derivative of composite function? Can someone tell me? Which rule we will use in finding the derivative of composite function? Zenavi, there is slight mistake in your answer. Please note it. Note the mistake and tell me the right answer. See, what question I am asking you, I am giving you a hint actually. How we shall find the derivative of composite function? Which rule comes for that? Please answer. Which rule we will use to find the derivative of composite function? Yes? Nobody knows which rule we will use? If we are asked to find the derivative of composite function, we can use chain rule, right? So here to find the differentiation of sin phi x, we are going to use the chain rule. Means what? First to differentiate sin phi x,